Hello and welcome back to another episode. So today, as you can probably tell by the title of the video, we are going to be going through Ohm's Law and Watt's Law and exploring what they are all about and also how to use them in a daily basis, whether you're an engineer or even an automotive technician. So quite often with Ohm's Law, you would use it to either find out the resistance or even the current which is going through a circuit. So to begin with, as you can see, so V equals volts, R is resistance, and I is current. So I'm going to begin with drawing a little diagram just so you are familiar with it and you know what to do and how to do it. So it all starts with this triangle that we use, where volts is at the top, resistance bottom left, and current bottom right. So if we were to add in some numbers into this and just get into the habit of calculating it and how to get a particular reading for, say, the current. So if we had to work out the current, so say if we had, let me just do a better diagram there. Okay, so there we are, that's better. So we all know a car battery has 12 volts, and so we have a resistance of, I don't know, let's just say 5. So we need to work out what the current is, and the way to do that is by dividing the volts by the resistance. And a great way to remember that as well, if you're turning your attention back to the diagram, if we are going up, we divide, and if we go across, we times. And there is a certain way how I actually remember that as well, and that's by remembering, if you were to put a calculation into your laptop computer, you don't actually have the divide symbol. You actually have the /. So that's a great way to remember how to do it and which way you do need to go. So if we were to divide 12 by 5, we would get 2.4 ohms. So that's pretty much it. It's very simple, very straightforward. If you do have any questions about this, feel free to put it in the comments below, and I'll be sure to get back to you as soon as I do see it. So yeah, it's pretty much straightforward, and again, it'll be the same thing if you were going the other way. So if you were trying to work out the voltage, you would then times the resistance by the current to then obviously get the voltage. Anyway, moving on to Watt's Law now. So quite a few of you may have heard from one of your friends that they have a say a 500 watt amp or even a 700 watt speakers in their car. So what you need to do is, it's fairly simple if you know how to do it, or if you understand how to do it. It is similar to Ohm's Law in terms of working it out. However, the symbols do change in terms of what each of them mean. So if we were to go through each of those first, I can then talk you through how to calculate the current draw and also the voltage drop, as well as how to work out what the maximum voltage is for a speaker as well. So we're going to go through that first and just talk about what each of them mean. So we would have P, which would be the power. I do apologise if my pricing on here isn't too great. I'm using a touchscreen laptop, so it's not that great. But yeah, so P would be for power, E would be for the volts. So again, as I said before, it has changed a little bit, and it can look a little bit daunting, but don't worry. Again, if you do have any questions, put them down below in the comments, and I'll be able to get back to you as soon as I can. And then I would be the current. Okay, so when it does come to working each of these out, a bit like Ohm's Law, if you wanted to find out the power, you would actually have to times E by I, which would give you the power. And if you were to find out the voltage, you would actually have to divide P by the current which is going through it, and that will then give you the volts. So moving on to how to work out the current, again, very simple. We just need to divide the power by the volts, which will then give you the current. Okay, so I'm going to be going through some diagrams for you now. One of which will be for a bulb and how to work out the current draw. The next one will be trying to find out what sort of power will be going through a what would also be going, what voltage drop would be going through the a resistor. And then for the final part of this video, I am going to be talking about also trying to find out the max volts going through a speaker, as well as also trying to work out the max what RMS is going to be running at. Okay, so first off, we are going to be going through the current draw. So I'm going to draw a little diagram first for you guys, which will be, as I said, it will be for a bulb. And this is what it will look like if you were to draw a circuit as well. So it's also a great way to learn what each of the symbols mean, as well as how to draw them as well. But it's going to be very simple because I may make a video in the future on how to draw circuits and what each of the symbols mean, because over time the symbols have actually changed. So yeah, I think that'd be another great video to make. But for now, we are going to be keeping it quite simple for you guys, just so you can follow along. And as I said in the previous video, and any video that I do in terms of any sort of engineering science, you can go through it by yourself as well, by adding in your own numbers and calculating it. And again, if you would like to add some comments to the video, stating what numbers you did change and the answer that you did get, you can always do that if you like. But without further ado, I'm going to be getting on with this now, and I am going to stop talking so much. Alright, so I'm just going to draw the circuit here. Okay, so for this bulb, I'm going to be talking about how to calculate the current draw, as I said previously. So for this bulb, I want 14 volts, and I want it running at let's say 1.12. Okay, so going back to how we do all the calculations and everything, we are going to be dividing the 1.12 by the 14. So let's just do that here now. So 1.12, and I'm going to be putting that there just so you understand what I am doing. So if you were to put that into a calculator, that will then give us a current draw of 8.0 milliamps. And again, if you are doing this sort of thing for a university assignment or a college assignment or exam, you do always want to make sure that you do put the unit at the very end, because if it is going to be getting marked, that will get flagged up, and you will need to correct it. So always make sure that you put the correct unit there, guys. Okay, so we've worked that out now, so that's quite straightforward and simple. So yeah. Right, so moving on to the voltage drop. Now, when you are working in a garage, you may need to do this a few times if a customer does come in with their vehicle and they do say, I think I'm losing a bit of power within the engine, and sometimes it can be down to any sort of electrical problem, whether it will be a component which is staying on even when you are no longer driving the car, or when the car is no longer turned on. So quite often as well, things like that can happen as well, because say if you were to have a 40 stereo and you think that you turn it off and it looks like it has gone off, but sometimes, quite often, it can stay on internally without you knowing, which can effectively drain the battery over time. And another thing that you can also use for this as well is, if you don't drive your car very much, it's also a great way to find out how good of a battery that you do have, because if you do leave a car standing there for too long, eventually the voltage of the battery will drop over time. So it's always best to get that engine running, even if you aren't going out that day. Just turn the engine over for, say, 5 minutes, let that alternator charge the battery, and you'll be completely fine in the future. Okay, so on to the next part anyway, for the voltage drop. So I'm going to be drawing a resistor here. And for this one, I want 100 ohms for this one. Just going to change the pen size. There we go. Right, so 100 ohms. There we are. Okay, and I also want to be working out, again, the voltage drop, because, as I said before, it is very important to do that. And I also want 5 milliamps. Okay, so again, I'm just going to be going back to the first slide for this, just so you can get a recap of what it is that we do need to be doing. So for this one, we are going to need to first calculate the 5 milliamps. And the way to write this as well, guys, because it is milliamps, it's not amps, it is milliamps. So it will be in a slightly different format when it comes to writing the equation out. So it's going to be 0.005, and we're going to be timesing it by the 100 ohms that we do have running through it. So once we've calculated that, it will then give us 0.5 volts. Okay, so we're not done yet. There is a little bit more to do in this. As I said at the start of the video, there is a little bit more to Watt's Law, which is why I did Ohm's Law first. So now we've done that first part, the second part that we do need to be doing is we now need to take the 0.5 of volts that we do have, which isn't a great lot. So yeah, we need to be doing that, and then we're going to need to times it by the by the 0.005, which will then give us, let me just quickly work it out, so 0.5 volts times 0.005, that will then give us 0.0025. And you can also put this in the calculator as well if you do wish to, just so you can see how it is that I'm doing it. So yeah, if you do put that in, you will get these at 0.025. Oh, sorry, made a bit of a mistake there. The extra 0 there. Okay, so if we were to simplify that now without the 0.00, that will then be 2.5 milliwatts. Again, don't forget those units. Okay, so the reason why we did that was to find out what resistor we need to put into that circuit, and also with resistors as well. The higher the resistor that you do put into a circuit, the more power it can dissipate. Alright guys, so that is it for the voltage drop now. So we are going to be moving on to finding out the maximum voltage going through a speaker. So I'm just going to quickly once again draw another diagram. I'll change the colour for this one. So this here is the symbol for a speaker within a diagram if you were to draw a circuit. Okay, so for this one, I want, let's say 8 ohms. Nice little number. And I also want 100 volt RMS. Okay, so as I said, we are going to be finding out the maximum voltage that we can put across the speaker when it is in full operation. So to do this, we are going to need to square root. Again, you can put this in the calculator as you are watching if you do wish to do so, just so you can get a better understanding. So we are going to be putting the 100 there. We're then going to be timesing it by the 8 ohms, which will then it will then give us an answer of 28.28 volts RMS. Okay. Right. Also, if you are wondering the method to use for this as well, it is a little bit different to the Ohms Law because, as you can see, it doesn't really go together. If you were to look at that, and also look at the equation that I have done. The reason why I have done a different equation for this is because I have had to combine Ohms Law and Watt's Law together, which is another reason why I did put Ohms Law and Watt's Law together in one video today. I understand it is a little bit longer than yesterday's video, but I thought it'd be better to put it all in one video, just so you do get a better understanding as to what is going on in one video, instead of watching just one video and then waiting for another video to come out to explain further. So the method that I have been using for this is if we were to work out E, you will then need to square root and then times power by the resistance. And then if we were to find out I, we would then square root with this, and we would then divide the power by the resistance. So that is another great way to calculate that as well, because there are different methods to use when you are working out anything within, whether it's engineering or within a garage. So I hope that does help. Another thing that we are going to be working out for the speaker that we have just done is we are going to be now, for the final part of the video, guys, we are going to be working out the maximum current, which is going to be going through that speaker. It is always best to be doing this as well, because if you are going to be fitting a speaker or an amp or a subwoofer or anything of the sort to your own vehicle, just to save yourself a little bit of money, if you do want to do it yourself, it is always best to do this as well, because you do want to be making sure how many amps are going to be coming out of your alternator. I have come across this problem many times before with some of my friends who have done this, and unfortunately, through no fault of their own, they have received complications with their vehicle for not doing this, which is another reason, once again, for making this video, because if you do install any sort of amp, again, speaker or subwoofer, you do want to make sure that you do have, or even you do want to make sure that your alternator can withstand the amount of current which is going through your electrical circuit in your vehicle. So without further ado, I will stop babbling on now about that. So we are going to be calculating the maximum current now. So again, we're going to be doing I, then square root again, and then power over resistance. So that is the method that we are going to be using now. So we're going to be taking the square root in the calculator again, 100 divided by 8. That's going to give you the maximum current coming out of those speakers when they are in full operation of 3.5 amps. Okay guys, so that is it for today's video. I hope you enjoyed. I hope it wasn't too complicated or long-winded. Again, I do apologise if I was talking for too long before eventually going through the calculations, but it is always best to make sure that all the viewers understand what is going on and why you do need to do these sort of things. But thank you for watching. Don't forget to subscribe and click the bell icon as well, so you are notified of another upload that I do. And yeah, thank you so much for watching. If you do have any questions, feel free to leave a comment. And yeah, take care.